Welcome everybody, and thank you very much for showing up here at SeaRUG on this beautiful spring day. Although I always thought the spring started on the 21st. I guess it's the 20th, I don't know. Equinox tomorrow, happy equinox if you care about the pagan holidays. I wanted to do something I haven't done in a pretty long time because we've got a pretty good crowd today. Who here is at SeaRUG for the first time? That's a lot of hands. That's very cool. Thank you for coming. Thank you for joining us, and I hope that you will find today's session informative. My name is David DenHerder. I'm currently the board president for SeaRUG, and so it's my pleasure to host you and to welcome you to SeaRUG, and I hope that you learned something here today. I'll get off the podium here pretty quickly and get to the fun stuff, but a couple of housekeeping items. First of all, we're going to very quickly go over the agenda. So today we are being sponsored by Quarry Group. Our very own Chris Hubbard is gracious enough to sponsor the presentation today. And I'm pretty excited about this one because it's something that I've been kind of talking about for a long time that I wanted to do, which is to bring somebody from the audience who does great work in Revit and bring them up here to show us all what's going on. So today I'm very happy to welcome David DenHerder, who is going to join us in a little bit and go through a presentation about Revit Systems and MEP. I've had the pleasure of working with David on a project some time ago, and it was kind of a fun experience for me because at the time David was working for Cezanne, an MEP consulting firm, on a project that Olsen Kundig was the architect on, and I worked at both those houses. I worked at Olsen Kundig, I worked at Cezanne. And at the time, I was working at BM Builders, who was the builder for that project. And it was kind of a fun experience. We did a lot of 3D scanning, point cloud, bringing into Revit. And then that was kind of a cool project because it was for Oculus, Facebook Oculus facility. And this is quite a few years ago now, before Iris VR and all those other things. And I like to tell the story that we won the award for that project because I photoshopped this development kit Oculus that we had. I put it under my hard hat, and I photoshopped this like interface thing of turning on things on and off, and I took a picture with the site in the background. I had a model overlaid, and we went into that interview telling Oculus that we could deliver a VR experience, not of the design, but of the fabrication to their project, and we were going to run the entire thing through VR. And the Facebook project manager said, I love it. You guys are hired. We want you to do that. To which I responded, oh, crap. I got to figure it out now. It was a pain in the neck, but we did it. There was a lot of David's model in that delivery. There was a lot of the fabrication model from our MEP partners. Olsen Kundig being the architect, open ceiling, you can imagine that they really cared a lot about where everything went exactly, and understanding the space was very critical. So that was really fun. So I look forward to David talking to us about MEP and Revit. It's been a while since we've talked about MEP and systems and connectors and all those things. So David knows his stuff, so it should be really good. Real quick, great thank you to all of our sponsors that make this happen for you. We're still a little bit light here on the industry partner side of things. For those of you that are new, I'll reiterate this. End of last year, we decided to change our sponsorship model a little bit. Due to the changing landscape in Autodesk resellers in town, we went basically from 4 resellers to 2 almost overnight, which meant that we lost about half our sponsors. So we had to get a little bit creative. And what we're hoping to do is attract more industry partners, people from the industry, architecture, engineering, construction firms that want to show off what they do and come and sponsor and present a meeting. So if you work somewhere and you think that you're doing something very cool in Revit, talk to your marketing department about doing a meeting. It's not only great marketing, but this is a great recruiting tool. I want you to come up here and tell us all why we should come work for your company. And if you're involved in manpower at all, you know that it's really difficult to find BIM talent. So this is a great place to recruit from the very, very best people in the industry here. Quick thank you to our SeaRUG board members. A handful of you are here today, so thank you for all the work that you do and putting together these meetings. And real quick, just upcoming event. Let's see, today is I think this is still relevant. I struggled to figure out if this has happened yet or not, but luckily it hasn't. I showed this last month, but I left it in. Basically, it's Dynamo user group meeting, which I think doesn't get enough love from us. This year I want to be a little bit more intentional about that. The Dynamo user group is a really great group, and they're doing really interesting stuff. So check it out. The information's up there. If you can go, this is really cool stuff. The more and more I get into Dynamo, the more I'm really impressed, and it's a lot of fun. So definitely come check it out. And hang out at the end of the meeting. Don't go anywhere. We've got a couple of Amazon gift cards to give away. The way that you get on that drawing is by RSVPing through Meetup. Your name will be on a list that I print out. I cut up the list, put it in a hat, and the presenter will help us take the names out of there. And you could win $25 from Amazon. So you must be present to win. And without any further ado, I think I'm going to just say a huge thank you to Quarry Group and invite Chris to come up and tell us a few things about Quarry. And then without any more from me, we'll just jump directly to the presentation. So Chris, thank you very much. And I'll pull up your presentation here. It's this one. There we go. Take it away. Thank you, Chris.
Thanks, guys. Sure, a lot of you guys know me. Been here since the very beginning of SeaRUG. I'm on the board, so I'm here frequently. For those of you that don't know what I do, I've been a BIM consultant since about 2007, helping architecture, construction, MEP firms work with their stuff. And we initially were founded because we saw this huge gap. We saw that people were transforming from a 2D to a 3D scenario, and we wanted to show people how to really ultimately utilize the 3D work. We've since sort of evolved into working on BIM strategies and BIM standards, as well as conversions, modeling, working with data. We've been really pushing the last year or so into data-driven design, data-driven QA, data-driven QC, things like that. Myself, I'm principal architect and one of the founders of Quarry Group. Been an architect for 27 years, continue to practice architecture. Used AutoCAD since release 9, if that means anything anymore. Found ArchiCAD very early on and said, hey, why are we using this stupid CAD software for? Why don't we use ArchiCAD? ArchiCAD kind of evolved for a while, and then Revit came on board, and not that I anything against ArchiCAD, but Revit's a better fit for me. I really like the data-driven design that it uses, things like that. Okay. So we just really quick, and as I want to get David up here to talk about his thing, we can develop specific strategies and standards for your firm, BIM-based, but it can also include graphic standards. We like adoption roadmap for future tools for databases, estimating, QA, QC, automation, generative design. Okay. We can also do modeling for people. We use intelligent objects and content, so we actually model everything. None of our drawings are drafted anymore. Everything comes live from the model. We QA, QC all of our work, which I think you'd be surprised how many people don't. And we provide real-time access to our clients via BIM 360 or our internal sharing site. We have both set up. We can use either one. And then we maintain data views for estimating, schedules, and QC. So some examples, we talked last month about some of our modeling that we do to automate things. Everything here was data-driven as well as model-driven, so we don't draft things. Okay. And then we've been developing a lot of automation tools lately. One of the things we really like to do with our clients is use the out-of-the-box tools or custom design tools instead of saying, oh yeah, you need to go buy this $5,000 piece of software to make this work. Revit comes with tons of tools that you can use out of the box to help you with your QC, to help you with automation, to help you with all those sorts of things. We also can host or connect to our client data. We have databases set up ready to host Revit data at any time. Very easy to connect to our database system that we can then push out through Power BI or Tableau or through a website. And then we can also develop import-export tools to bring geometry in and out of Revit through Dynamo C or Python. So some examples of our color coding. So we developed a color coding Dynamo up here, and we've also got a Power BI web here that's keeping track of embeds for one of our current projects, and then some C code that we can write to help import-export the Revit data. So that's it. Without that, I'll go ahead and introduce David, who's over here now.
So get used to how this sounds. I'm David DenHerder, and I'll just give a bit of background. I started working with Revit MEP back in 2007, 2008, up in Alaska where I lived in Anchorage, and I was for Kaufman Engineers. And then in 2012, I moved down here to Seattle and worked at Kaufman, and then at Cezanne Group, and then at AEI. And then last year, about this time, I left AEI and have been out working independently and as a contractor and consultant. And so it's a bit awkward because my competitor kind of sponsored me, except that I'm not much of a competitor because I've just had the one client. And so then my client has been Lee Crutcher Lewis, and all my work in the last year has been structural. And so I've kind of had to dig back to some of my older projects and remember a little bit, but I have a lot, and as I was going through it, I realized, yeah, I still remember quite a bit of this, and I did a little bit of research into what's new with 2019, 2018, trying to get myself up to date a little bit, but and then a lot of the fundamentals still haven't changed much. So this is a survey of systems in Revit Systems, formerly known as MEP, and so in Revit, you have the systems, you have the different kinds of systems between electrical, pipe, duct, and cable tray and conduit. And what the platform or the software uses to generate or keep track of or organize the systems is the connectors that are built into the various families. And the connector elements have all these. There we are. They're defined by, or rather, I should say that the connectors define these systems, depending on the kind you pick. And then once you have families placed that have these connectors, then you can select those families and then add them to systems. And you can name the systems. You can schedule them. You can pull up a system browser, which I'll show shortly, to keep track of them all. And then one thing to note that these systems that's shown here, they're classifications, and there are only these classifications are available, which sounds limiting at first, but then once you've started a system, you can have different system types within the classification. So on my next slide, I have some miscellaneous features like that, and then where I talk about that, and number 4, it says, while system classifications are limited to the ones listed in the previous list, within each classification you can have as many types as you need, except for conduit and cable tray. So you can have chilled water supply and return, you can have hot water supply and return, you can have high pressure steam, low pressure steam, medium pressure steam, you can have as many as you need as you want to define all the systems in your building. And the same could be said for electrical, except that electrical systems, specifically power, are defined or grouped, organized by panels, which makes sense. So in some ways it works a little bit differently than piping systems or duct systems. The only thing that I've found to be a little limiting is with conduits and cable tray, because especially conduits, because you have conduits for power, different kinds of power, low voltage, high voltage, signal. You have conduits for all kinds of different things, but there's no way to have system types. So you can't have a power conduit system type, you can't have a low voltage system type, and so on. And the way around that is just have a parameter or two, add that to the. Is everybody hearing me all right? Okay, cool. So you can add a parameter or two to the conduit or cable tray system to allow you to filter and schedule and organize and keep track of networks or however it is you're trying to classify or organize your systems in electrical systems. So another feature with pipe and duct systems is, it used to be that if you wanted to have, in a plan view, especially like a working plan view or a plan view, you wanted to be able to differentiate between systems by colors. It used to be you had to create filters and override them in view. But after, I think it was 2016 or 2017, they built that into the system properties. And so then, it didn't matter what view you're in, they'll always show up based on the system properties. And then I worked at one place where they wanted to have on the sheet views to be black. And so we'd put a view template filter on the sheet views that make all the systems black, just so it would print out the way they wanted to see them. And there's some ins and outs, some tricks and tips on hierarchy of filters and visibilities, and some of that I've discovered, and you have to sort through whether the filter overrides the system or the system overrides or the view, or anyway, there's a lot of that. And then electrical systems, they can all be circuited, and I have circuited in quotes because really you only circuit power systems to a panel schedule. But on one project I was using for data, a data technology design, and I set up a patch panel family that I would use as a panel board to keep track of data outlets around the project, and I had some success with that because I could then manage the tagging and the naming of the outlets just in one spot, instead of having to go out to the plan and click every single one and change it. I could change it in a schedule, and then I could just have the schedule and be able to pull that up and get counts and everything else that goes along with schedules. And so that can be useful. And then there are another thing that I have is there are two different kinds of conduit and cable tray types, and you may have seen these where you have cable trays with fittings and cable trays without fittings. And for a while I didn't know what that was about, but there may be other things that are useful. But what I found to be really useful is that if you use without fittings, you can pull up a length of the entire run. So if you're trying to determine your longest run in a building, from say a patch panel to the furthest room with the furthest outlet, you can model a conduit all the way to the end using without fittings, and then pull up the length of that conduit. And it should be accurate provided you model the conduit where it's actually going to go. And so that can be pretty useful, as anybody who's tried to find longest runs for a data network would probably know. And there could be other uses. There may be other features. Does anybody know of any other features that are different between with or without fittings besides that one? What's that? Angles. Okay. Oh, okay. So he just said that you can also calculate how many turns or how many degrees of turns you have in a run, whereas I suppose with the with fittings you can't do that. And being able to do that is pretty handy too. And then this last slide is empty because in fact, I'm just going to add what I just found out about that. Oh, and maybe I can't do that now. So also you. So, and then I hope to be a bit more interactive as we get going. People will know things that I haven't learned too. I feel like I've learned a lot over the years, but every time I come to a new company, I've learned something new just because somebody else has been doing it that way, and I never even saw that button over there in the corner. And then I saw it, and then I've used it. So I'm hoping to add a few more things to this list here. If anybody has any tips or ideas that I may have missed as I go along here. So I think what I'll do now is start out with just kind of from scratch, sort of. I modeled my house in Revit, and sorry, pardon the Revit screen didn't show up very well here, but I think everything that's important is showing, so we'll just go with that. So I set up I'll start with say a ventilation plan here. And just pull this over to get more room. So I have some supply diffusers. This house was built in 1957, and so a lot of the original stuff is still there. And so one thing you'll notice right away is when I click on this, you get this little symbol that shows up. This is a connector. This little white square with the cross in the middle of it. That indicates that it's a connector for ventilation. And this little blue symbol off to the side is representative of a typical supply symbol. Over here, that is another supply duct, a supply grill that goes into the furnace room right here. And it's up high, and then down here I have the return grill, and it shows the typical slash, that symbol that shows up mostly in the mechanical field. Is that stuff showing up on it? Okay, cool. And then there's another supply duct. There's only one return grill in this house. Then over here I have an exhaust fan, and it shows, no, I don't have an exhaust fan in here yet, so let me place one. These, I can't remember. I know I used some custom families, but this one, this cabinet I'm putting in, this exhauster cabinet, is out of the box, I think. Yeah, I'm going to put that in the reflective ceiling plan because it needs to be, what's the ceiling? And of course, as Revit usually does, it does something I'm not expecting. And anyway, so here it is. And you'll notice there's two connector symbols on here. The one connector symbol has a little lightning by it, and that means it's a power system connected to power. And then this is the exhaust symbol for an exhaust system. Now there's one other system for duct or system classification, which is other. And that can be used, in fact, that would be something I might use if I had a furnace in here with an outside air pipe and an exhaust pipe. I might use the other system and make a type called outside air or boiler air intake or something like that. I should probably just get a boiler in here. Actually, here's a boiler. So here's a condensing boiler, and you'll see there's an exhaust outlet there. Now this, I don't know, I don't know if it has a, let's see here. So sometimes in a family from a front view, from a top view, you'll have connectors that are above and below each other. So I'm pretty sure that there's something underneath here. So if I hit tab, or I click on this, and I go to, when I click on that, it'll tell me I can create these systems based on the connectors that are here. Now, I don't know if this has, let me just edit the family and see what we got. I can put and by the way, in a family editor, these are what the connectors look like. They have this little arrow. The thing to be careful of with these arrows is that these arrows don't mean that the fluid or whatever is coming out. These arrows mean that when you route pipe or duct to it, that means the arrow indicates the direction that the pipe will come out from the model family. So if you reverse it, then if you clicked on it in the Revit project environment and you wanted to draw a pipe, it's going to want to draw it into the boiler instead of out the back. In most cases, you don't want that. To indicate whether it's in or out, then you would go to the properties and check the flow direction. In this case, it's out. If it's in, change it back to out. Now, one thing, okay, so I was looking for, okay, so here's exhaust. I wonder if there's not really a, what is this? That is gas in, okay? So I'll just, actually, I think I'll just do this. I'll take this. It might be easier there. And go back to 3D view. And there's that. And then I'm going to put a create. And then when you go to create, if you can do, of course, the extrusions and sweeps and stuff. But what I'm looking for is the connectors. And then here I can put in any connectors that I want. And I could put a cable tray connector on the back of this. And if I click on it, I could draw a cable tray off the back of the boiler. Well, that doesn't, of course, make sense. But the point is that you can use any connector you want to host any geometry in a family that you want. And so there's, of course, flexibility that way. So I'm looking for a duct connector. And when you click that, you can either host to a face, in which case I'll host to that. You can also determine what classification is going to be. You have exhaust air, other, return, and supply. I'm not going to get into fitting and global right now. They're used mainly for when you have you have a more generic family that you don't have to create a type for every. Say you have several systems in a project, and you don't want to have a type for every single system type. You can just have a global, and it will take whatever. I think that's how that works. Anyway, and then the fitting is only what you'd use for a fitting, and then it takes the properties of whatever it's attached to. So I'm going to ignore those for now, but I'm looking for, I'll just do an other air, and I'll put that there, and I need it to be round, so I'll go to properties, and I'll change it to round, and then I'm going to want this to be in, and now I can't change it to boiler intake here. Only thing I can do is determine the classification. So then I don't want it to be that big, so I'll just make it, and whatever it's just this one is. This is tied to a parameter radius, so I'll just tie it to the same parameter. I can either type the radius in here, or I can set it to a parameter. Once it's in the parameter, then you can change that radius in the family, or in the project environment, without having to open the family editor. So I'm just going to go ahead and do that. It was vent radius. And if they're the same, it doesn't matter. Normally, I would probably, if I was going to have several different versions of this family, that might need to have a different diameter for intake and exhaust, I would have to set up another parameter for outside air or intake. But in this case, I'm not going to do that. So I'll load it back in the project. And now I have this other one, and you notice it doesn't have a symbol on it because it's not exhaust, it's not return or supply, it's just other. And so Revit throws in this generic box, cross mark, whatever. So what do I have for systems in this project? Under families, you have cable trays. Those aren't cable trays, and conduits don't have systems, so that doesn't work. You have duct fittings, duct systems, and ducts. I'm going to go into duct systems, and I'm going to go outside air, and I'm going to edit this. I'm going to duplicate it, and I'm going to call it boiler. Intake. So in this window, there are several things that are going on here. Okay, this is a holdover from Okay, so this is a material override. And I'll just go through each one of these things because these are all things that are helpful to know. So first of all, you have graphic overrides. This is where you can determine what the line work looks like in a project or in a view. You can change the pattern of the line type. For now, there's no override. This is the color that has been assigned to this particular system, and you can change the weight of it there. And everybody's probably familiar with this collection of options, and it works similar to that. Now here, if you want it to show shaded or to look like a gray duct, no matter what view you're in, then you have to apply a material to it, and otherwise it will use the default material out of the box, which is just a basic gray, and all your ducts, no matter what system they are, will look gray. However, they will have an outline of whatever color that is they are. So if you're using a shaded view, you'll see gray with blue or red or whatever it is based on that. But if you want the entire duct to be red or blue or gray or whatever it is, then you need to do a material override. And I have a few here. I have duct system for exhaust, outside air return, and so on. I'm just going to use outside air because that's technically what it is. And the abbreviation that will show up in tags is OA. I think I'll just go with that. If I had a bigger building with more systems, I would probably do, say, OA-1. And then if I had another outside air system with a couple of different AHUs, I could have OA-2. Or in some cases, I might even tailor the abbreviation to what the system is called. And I will show you what that looks like a little bit later in a different project where I have systems already built and developed. You can also determine what the symbol looks like, or rise and drop. You can choose any one of these. So I know normally in a mechanical plan, when the duct is going up for supply, it's a cross and it's filled. If it's going down, it's an unfilled cross, and Revit should automatically dash it for when it's hidden. I think it's been a while since I've worked with that. And slash to return, backslash. Some places I worked at wanted to use a slash to return and a backslash for exhaust. It depends. The one thing you have to be careful of, though, is if you're used to seeing this yin-yang symbol for round duct, regardless of the system, this isn't going to work, because this yin-yang symbol will only show up if you're using round duct. But you also have to make all your systems reference the yin-yang symbol, so it will show yin-yang. So people who are used to seeing the yin-yang symbol on their old mechanical plans started seeing this, this instead for supply and this instead for return. And the problem with changing them all to this is that you lose the benefit of being able to differentiate between the two systems. So there are a few compromises you have to decide here and there. So anyway, this is going to be outside air. I'll just do this. Differentiate. I'll just do reverse wide, differentiate it from exhaust filled. Okay. OA and so on. Here is a water heater. So I'm probably not going to get into a whole lot of modeling because I'm more interested in the systems. One thing that I've seen people who are new to Revit MEP, they start working on a big project and they start working out their ducts and their duct types, or even worse, they'll start doing their piping systems or their pipe types, and their thinking is, okay, well, we aren't really interested in systems at this point. We just want to get sanitary pipe. We want to have the different pipe types here, and so they would rename these pipe types based on what they're being used for. So we have PVC, DWV, and then they would rename that our sanitary waste pipe, and then they would go through and they go copper. They just rename that domestic water, domestic hot water, domestic cold water, and then they would connect them to all their families out of the box, which have the system connectors onto them, and then they try to filter it, and it doesn't filter right because they're filtering. They're not the filters are using the system information, not the pipe type information. And so you have to be careful of that if you're not used to that, if you're just starting out. So for example, we have a hydronic supply system here. So I'm going to create pipe. And I'll just go ahead with the hydronic supply, 2 inches, so on. Hit OK. Now, it's going to place pipe. So here's a pipe. And I'll just go that way. And what kind of pipe did it use? It used copper. And copper fitting, and so on. But usually, you want to use threaded steel for pipes. Typically, it's under 2.5 inches. So I'll just take this run, and let's see here. I'm just going to take these 2 pipes. I know there's probably another trick, but I have forgotten it, and just change it to Schedule 40 threaded with T's. Okay, so then it looks about the same. No, it doesn't. I didn't actually change it. Here we are. Okay, now the fitting is still a copper fitting, and I can either take the copper fitting and change it to a elbow threaded, but I find that it makes a cleaner model if you were to just delete it and then trim it, and it will throw in the correct geometry for a threaded fitting. And I just know from experience that if you have fittings of different sizes and you convert them, sometimes the geometry won't change like you think it's going to change. And most of the time it will work, but when it's critical, it won't, and you won't know why something's not working right. Anyway, I could also take here, let's do the return, and I could go here and I could select PVC pipe. And then you have your PVC fitting. And so the thing to be careful of is when you go over here, let's see, I don't want to explain that. But the thing to be careful is not to equate the pipe types, which is the actual material, fittings, and everything with the systems. Because the pipes can host any kind of system they want. They can host, they can run any kind of domestic water, hot water, cold water return, all that stuff. And the same can go for, well, ductwork isn't quite as flexible as pipe type, so I'm not going to worry about that too much. I mean, technically, I don't have the flange pipe fitting built in, but I could draw a flange black iron, or not black iron, but flange fittings off of this 3/4 inch if I had those fittings in my project, and that wouldn't be correct, but Revit would allow it. There are ways to set up your pipe types so you can limit it to certain sizes, but I'm not going to get into that at this point. So one other thing I might go to is, so let's take this water heater, and we've got a sanitary out. You can tell by the P-trap. That means it's going to go to the sanitary sewer system. This is a power. Then we have domestic hot water. It looks like a faucet with the hot water coming out of it. And then we have this faucet. Oh, we have 2 symbols on top of each other. We have a cold water and then an exhaust outlet. So one thing you can do, and one thing I found after I got used to using systems and working with them, is before I'd even run any pipes or duct, I'd actually build my system first. So I would take this hot water heater and I would go to piping, and it'll create a piping system. And because there's all those connectors on it, I need to choose what system type I want to do. And I don't have domestic water in here? I do have it here. Domestic hot water. Why does it not let me do that? Oh, maybe because I've already assigned it. So if I go like this and I go to piping systems, I can see I already have a domestic hot water and cold water. It's already been hooked up. So then it won't try to create a system it's already attached to. So I'll hit piping, and it does have a sanitary waste. So I haven't set up a sanitary waste system. So I'll go ahead and click that, and I'll just call it W1, the system name, and then open the system editor. Now in the system editor, I can go and I can add other items to it. So I'll just go add a system, I can add the toilet, I can add the sink, I can add this sink. I don't know if I have anything else here. Refrigerator, does that have a? It says I can. Maybe it has a little drain for the ice system. Oh, there's a tub. I need that. I'll just add this and see what happens. No, I can't. So it says there's no available connector matching the system type for the system. So I can't do that. So that's fine. If I had a boiler in here with a condensate drain, I could add that. This boiler, does that have a condensate drain? Apparently it has a condensate drain. Okay, I don't think I have anything else. So then I hit OK, finish editing the system. Now, you can hover over an element and tab select and tab over it and hit tab, and it will highlight things that are part of that system. So this water closet has actually two systems assigned to it. It has domestic cold water and then waste. So when I tab over it, it's going to cycle through the two systems. So I hit tab. The dash line indicates the box around all the elements that are apparently cold water. And then if I hit tab again, that allows me to select them all. Hit tab again. That is apparently the waste. And you can see the little, does it show up there? Yeah, the little pop-up shows what system is being tabbed over or selected. Hit tab again, I can select all the elements that are part of piping system 1. Similarly, I can do the similar thing for ductwork or for duct systems. So I don't think I have a system set up apparently, so I'll hit duct, and I'm going to call it supplier 1, SA1, and I'll open it in system editor, which I didn't, so I'll just do this here. I can add this, add that one, that one, that one, that one, that one, and say I decide to try to add this one, which is a return register. It'll say I cannot do it because there's no supply or connector on that. If I had a furnace in here, I would add that. I don't. Finish editing system. One thing you notice is they have kind of turned blue. Have kind of a dark blue setup for this system. So these have turned blue. This is already reddish, so it must already be part of a system. So I think it is. So then I'll just go to here and I can look at that duct system, and it's mechanical return error 1. That's what it's called. So let's see. Now I can show that in the other project. Let's see. Here's a hose bib. It looks like, okay, it's already part of a system too. So now I have all these elements that are part of a system. There's nothing connecting them. I'm not going to get into that right now. I want to pull up the system browser, which is under View. And it allows you to look at systems or zones. I don't have any zones set up, so I'm not going to look at those. You can also filter it by discipline. So if you don't want to see all the rest of them, I can just go mechanical. And it tells me there are 6 unassigned items. They're mechanical, exhaust air, condensing boiler, dryer. I didn't assign dryer. Okay, exhaust cabinet, water heater, exhaust. Other air, condensing boiler, that would be the outside air that I put on there. And then return air, register. It's not assigned to system. And then these are the ones that are. Where's that return register? Actually, where did it show up? Oh, that must be a mistake. Leave that out. So that was pretty useful, actually, because I can go through and just find out what elements don't belong, and if I find, or they're not connected, and then I can find them out, and then connect them to a system if they need to be connected. So right here, I have the one return duct right there, and then here for SA1, I have all these registers. And you notice that when I clicked on the system, the elements were highlighted, and the box showed up, kind of a general outline of where they are. And the same for return error 1. Can I rename that here? No, I can't rename that here. I want the name to match, so I'm going to go here. I'm going to select this. Properties. Not used to working on this small screen, so yeah. Here we are. Edit type, and I'm going to rename. Oops. Not escape, or function 1, or whatever it was. Oh, here we are, yeah. Okay, so hit OK. And now it's RA1. Okay, so I don't want to spend all my time right now. What time is it? Okay, so I'm going to hop over to the other project where I have actually fully developed mechanical systems. It's a smaller medical office building. Pull this over to here. And I will go to, what have I got here? Okay, here's a new foundation slumbing plan. So you can see here, everything's colored. The waste system is brown, the waste vent is green. This is all apparently filtered for sanitary and vent. Here you can see the duct systems. Here's, what is this? Expansion tank. So that would be red because it's part of this hydronic system. That's foundation, so that means it's below it. Here we are. Here's a new one. The new domestic water. So now that we're looking at this, I want to pull up the system browser, and we can take a look at that. So it shows I have 30 unassigned things. A lot of times these are just miscellaneous one-off things. Wall hydrants. Not sure why those are. They are the way they are. I'm not going to worry about them too much. Back to here. So here we have all the piping systems in the project. Chill water return, it's called CWR, chill water supply. Domestic cold water, hot water, circulating gas, heating water return supply, other, which is an air separator. Sanitary vent, sanitary waste. There have been many times when I wished I could export this to Excel or something. As far as I know, there's not a way to do that. Because there's some interesting data you can get out of here. If the systems are built properly, there's some data you can get out of here. So right now it's showing flow, size, and pressure drop. Looks like I'm getting some.
David, can I ask you a question?
Yeah.
Related to this a little bit, it's a little bit more about modeling than it is about systems.
Yeah.
You get a lot of really important information out of this if the system's modeled correctly.
Mm-hmm.
It's a little bit of a philosophical choice. I remember the conversation when I was with you for this kind of stuff. Is mechanical plan, like say a piping plan, is meant to graphically show a certain thing.
Yeah.
And when you model the pipes where they really go,
Yeah.
you don't get graphically. But yet,
Right.
if you model it where it really goes, you get a bunch of benefit out of it from a coordination standpoint,
Right.
from a calculation standpoint. Has
Mhm.
the needle moved at all in that conversation? Letting
I think it's getting, the last place I worked at AEI, they were modeling all their pipes to where they should go. And they looked readable for the most part. There are things you can do to, like if you have pipes that are stacked and stuff are too close together for the symbols to look right and everything, there are things you can do with tagging or even different views, setting up another view or two, or enlarging a view or whatever to get all the information on there. It's not going to look like your old normal, what you're used to for a layout, but there are ways to get around that. And I think, depending on the company you're with, it depends. It varies, really. Yeah. And so I've done different. I prefer to show everything in double line. A lot of people don't like that. And that's just my own personal preference. As you can see from this plan, I use double line. And of course, the fittings are small. You don't have the pipe ups and downs. But I would typically cover that with a tag. So I would put a tag on it and say 3/4 inch pipe up, whatever it is. If I were to change this to single line, which is a matter of just changing this, I would get this. Valves are different sizes. It's very difficult, I don't know if you can or not, to get consistent sizes for ups and downs and fittings, because if you have different sized pipes, the fittings will grow or shrink depending on the size of the pipe. And a lot of times, people who are interested in having a clean, diagrammatic style layout want the symbols to be all the same size, and there's not really any way to do that. So you're forced to have compromises in some ways. So I typically prefer this, but that's kind of my personal preference, and I usually try to capture things with tags instead. So, yeah, go ahead.
I think one of the things that people might want to understand about this is that the architects put in scope boxes, so the architects are using different view ranges.
Yeah.
A lot of times our pipe is sitting higher or lower.
Yeah.
Than what a standard view range is going to be in there. So our sheets sometimes look different than the architect's set.
Mm-hmm.
And we get pinged a lot of times for that.
Okay.
Especially with link files, we don't show our views by link views, we
Right.
by host.
Yeah.
So our cut plans will make our views look different.
Yeah.
Than everybody else. To answer David's question, we model for coordination and clash detection.
Mhm.
So we will forego it looking pretty at the
Right.
sheet,
Yeah.
so we get the information.
Yeah. Yeah. And there are things to be careful of that too, because I remember an instance where the person modeled the pipe over to the wall and then ran it up over the ceiling, and the cut plane didn't show that there were some high windows there. And so when you're modeling a pipe, it's important to actually take a section view and go look at what you're actually doing, because you may be running across something that you don't see in this particular view range. So, okay, I know what I was going to look at. I was going to look at the system, the things you can see in a system browser. So you have this column settings. Under general, you can have flow, size, room name, service number, and all that, static pressure, and pressure drop. You can have system classification if you want to see that, direction, flow factor. I'm not sure what some of these are. I know static, I understand those. A word about static pressure and pressure drop. Revit has long said that they can do that for both ducts and pipes, but it takes a lot of massaging, and you might not get it to work anyway. I think that has improved with 2018 and 2019, but I haven't had a chance to test it out. But the thing is, you can still get good information, even if you can't get a static pressure or a pressure drop, which is kind of the big numbers for determining and selecting equipment, that kind of thing. You can still get things like friction or flow or things like that you can use for sizing pipes and ducts. And I've used that to help out engineers. I set up a view with a duct system, tag the size of the duct, tag the flow, and did I do the friction or not? But anyway, I can't remember now. So I did an ISO, and I gave that to her, and she, instead of having to take a scale and measure the plans over the length of the ducts to put it into her spreadsheet, she could just look at this and say, okay, this duct is 6 inches, with 100 CFM, it goes to the next fitting here, and then another one adds on for another 200 CFM, and that 200 CFM has got 5 feet, 9 inches or whatever. Instead of having to measure that, she could just plug the numbers into her spreadsheet that way, instead of having to, and so it was a big help just being able to do that. I'm going to take the pressure drop off and take static pressure off because I don't really have any of that set up. I'll keep size, but I see the size is not really showing here. I'll just leave it on in case it's under some of these T's here. Mechanical, and take that off. One thing that's kind of cool is volume. If a system is built with fixtures and pipes and it's connected properly with no warnings, it'll pull up a volume based on the pipe sizes and lengths and whatever volume is assigned to equipment. So that can be pretty useful. I don't have any electrical here, so I'm not going to mess with that for the moment. So I'll turn these on. Okay, so I'm getting volumes for vent, which actually doesn't make sense. Not really for that either, but here's where we want to see volume. So here I have 2 different, a weekday system, and there should be a weekend system, because they were going to have 2 different systems set up for weekend use and weekday use instead of having to set up, I can't remember the particular reason for that or how that design worked. But anyway, I ended up setting up a weekday system and a weekend system and actually running 2 sets of pipes for each system. And so it was nice to be able to keep track of that. Heating water supply, a boiler loop and weekday. It must be the other one is just, anyway, I can't remember now, it's been a couple of years. There's a gas one. Volumes, but for a heating water return and supply, knowing the volume can be useful for determining your expansion tank size, things like that. And we have chilled water return and supply. The volumes aren't calculated, so that tells me that I may have an open pipe somewhere, or I have a piece of equipment that's not built right. And I have some unassigned piping. Anyway, so that's mechanical piping and ductwork. I kind of leaned heavily on that one, mainly because I know that better. But I'm going to go back and try to do a little bit of electrical. So I'm going to go back to the house and start putting things in. And I'm going to hold off that for the moment, and I'm going to go into the electrical plan. And I don't even know if I have anything loaded up yet. So I'm not quite as prepared as I'd like to be. Last week, Dave contacted me and said, hey, somebody bailed out, and am I ready to go? And I thought, oh yeah, sounds great. And I asked my wife about what we had going this weekend, and she said, oh, don't have anything going. And then the next day, found out we were going to get 20 yards of wood chips. And the neighbors had the space, and they dropped 20 yards of wood chips in the neighbor's lawn, and I helped my wife the rest of the week moving wood chips. And so I'd like to have more showing here, but I don't. So I need electrical equipment. So I'm just going to load in some stuff out of the box. So the interesting thing about electrical, when I first started using Revit in 2007, 2008, 2009, the electrical department was the one to resist the most, because they didn't want to worry about 3D. All they did is put their symbols on the plans and interpret them. And they didn't like getting complaints from the architect, why the light fixtures on the floor, or why are the light switches spaced 2 feet apart on the walls all the way down the wall. And that's because it looked right on the plans. But then I noticed that as years went by, the last company I worked at, AEI, their electrical department was considerably further along with systems and the features than mechanical, because they realized that they could keep track of all their panel schedules in Revit. They had to do some major tweaking to get it to work. Once they got it to work, they were ready, and they never, on their newest project, they didn't use Excel for panel schedules. They did all their panels scheduled in Revit, and what I saw of it when I helped out, I was pretty impressed. And so what I've been seeing is electrical departments, once they realized how well the data could be handled, they started getting further into Revit and developing it more than some mechanical and plumbing places. Okay, so I'm looking for, yeah, I'll just do one of these, just so I can get some circuits, and I'm going to place electrical equipment, and I think I have a panel over here. Okay, and now I'm going to place some outlets. Do I have anything here? No, I don't have anything here, so I'm going to go ahead and when you do this and pull out this tab, you'll see that there's cable tray conduits, electrical equipment, and there's a drop down for the different devices. And these are the various electrical systems that are available, telephone security and so on. I'm going to go for electrical fixture. I don't have any loaded, so I'm going to load one. Okay, that's not right. This looks different somehow. There we are, receptacles. So I'm just going to get a duplex receptacle. I just put a few around the place. I think I have one. We have one over here. We have one, I don't know, over here. And we got one over here, and here, and here. Now the symbols aren't showing anything because I have fines. I'm going to go to medium, and that will show up the symbols. Now they're all GFCIs, which is fine. So now I want to circuit these. So similar to the mechanical or plumbing and piping and ductwork, I can select this and create a power system. And then it'll ask me what panel I want to use. And I don't have a name. Oh, maybe. Okay, I might have the wrong. Yeah. Okay. I'm not electrical, so I don't know. I think there's something wrong with the distribution system, which is the reason why it's not recognizing. If anybody has any ideas, let me know. Okay. Oh, no. Panel properties? Is it a type property? Load classification, is that what it is? Power. It should be a different family altogether?
No, it should be, where you're looking, it should be instance parameters.
Oh, okay. Okay, so down to, oh, here we are, okay. Oh, I wonder if it's because I don't have any actually built in. So, yeah, let's go to manage. That would be, distribution systems. Okay, I'm getting way over my head. A lot of the projects I've worked in, I've already got all this stuff set up, and I think I built this from an empty template, so I'm in over my head on this one. So then instead, I will run some conduit, because I can do that. So I'm going to go to the technology plan, and I'm going to go, I have a modem over here, and I'm building an office over here, so I have to run a cable, so I don't have to use Wi-Fi from this far away. So what I really did, I just took a tape measure, measured up, measured over, and so on, and I would figure out my cable length. But if I had been thinking, I could have done this. Gone to here, let's get a second view. This. Go to systems, and I want to do electrical, conduit, I have a feeling. Conduit without fittings, I'm going to do that. I'm going to go like this, and I'm going to just say 3/4 inch. It's about here. I'll go up to here, go over, and I went up through here. Let me do that. Oh, I don't have any fittings loaded. Well, I think I'm running out of time, so, and I wasn't really ready, so, for this kind of stuff. So anyway, I wish I'd gone over more of the conduits and the electrical, but I knew coming into it there was going to be a lot, and I wasn't sure if I was going to be able to get through it all anyway. So, did anybody have any questions now, or do we have time for that, Dave, or? Yeah, yeah, we can do that too. I have some time afterwards if you want to talk some more, too. So. Yeah. You mean for the, yeah, you can't make new ones. Yeah, you can't make new ones. I've looked into that.
And then if you're adding components to a system, can you add them to that system even if they don't have the direct connection?
No. You have to place a connection on them, so yeah. Yeah, and so for example, one thing I might want to do in a theoretical situation, I could take and go to my, I just go to my plumbing plan, and say I wanted to have my hot water heater hooked up to an automatic system that tracks water heater usage, and I had a central panel somewhere where I keep track of all my stuff in my house. I would put a data connection on that panel, and I'd put a data connection on that water heater, and then tie them together in a system. I wouldn't even know if I bothered with conduit or not, but I would just assign them to the same system. But I'd have to put the data connection on the water heater if I wanted to do that, or the furnace, or whatever it is, like a building control system or something like that. But you have to modify it to add the connectors that you need to do that. Yeah. Yeah. So is that your hat?
That is my hat. Well, thank you very much, David, and thank you, Chris, for sponsoring.